Here we'll review some of the key recalibration methods available in AutoLogis. You can see in the results from this example dataset that the instrument calibration was a little bit off. And that's why the mass errors associated with the assignments are not centered on 0 and instead have this trend. One of the benefits of the AutoLogis method for peak assignment is that this spectrum has been successfully assigned using the inference network approach, even though the underlying data had this systematic mass error. However, applying an internal recalibration will provide a benefit in that it will reveal some of the underlying statistics associated with the mass errors, and which we can then use to improve or understand the confidence we might have in our assignments. So AutoLogis offers many different options for mass recalibration, and that's what we'll look at in this video. The first recalibration option is conceptually the simplest, but it is likely to be used only rarely. In this method, you, the user, will choose exactly where to draw the recalibration line. On the mass error by mass plot, set this menu to recalibration mode, set the recalibration style to polynomial, and choose the cursor tool from the Graph Tools palette. Then you can add calibration points onto the graph simply by double-clicking in the place you wish to put them. Then to apply this recalibration line, you'd simply click the Apply Recal Data button. But clearly this isn't a particularly good recalibration curve, so how can we use AutoLogis to do a better job for us? To find the more advanced recalibration options, you need to switch to the Recalibration tab. Using this control, you can access a variety of more advanced recalibration options. The first one of these that we'll look at is the 48 Dalton ladder. The 48 Dalton ladder will generate an internal recalibration list that comprises a pseudo-homologous series that starts with the most abundant assigned peak in the spectrum, and then steps out from that in 48 Dalton steps across the entire mass spectral range. And 48 Daltons here corresponds roughly to steps of CH2O2. And we access it just by clicking Get 48 Dalton Ladder. So AutoLogis has found the corresponding ionic formulae from the peak list and has entered that information in this recalibration list control. It also gathered the peak masses and the associated mass errors and has updated the recalibration curve in the mass error by mass plot. This method of finding an internal recalibration function is broadly akin to standard manual methods for internally recalibrating complex organic matter spectra. But because errors are statistically distributed, the more points you have in your internal recalibration function, the lower you would expect the overall global error to be, providing that is your assignments are correct. But as AutoLogis isn't limited by the slow speed of manual processing, it can use much larger sets of recalibration points. So let's look at what happens when we use all the current assignments for internal recalibration. To import all current assignments into the recalibration list, click Get All Current Assignments. That will cause AutoLogis to import all of the assigned formulae into the recalibration list. And it's updated the recalibration curve information as well. You can tell from these two controls that currently AutoLogis is fitting a fifth order polynomial to the recalibration data. Having processed a lot of this sort of data with AutoLogis, I found that a fifth order polynomial usually works well, and that's always where I start. But you can easily change the order of the polynomial simply by changing the number in the box. Now to recalibrate the data using that curve, we click the Apply Recal Data button. This is the style of recalibration that I use most often when I'm processing data myself. However, AutoLogis offers two more advanced modes for those who need to use them. These modes are called Tracker and Walker, and are alternatives to a polynomial fit. You can access Tracker mode by changing the recalibration mode dropdown. Tracker mode is designed to correct for large-scale mass error trends in your dataset, and it does it by applying a long-range median filter to the mass errors, and then fitting a high-order polynomial to that filtered result. So having selected Tracker mode, we can get it to run by again importing all current assignments by clicking here. So Tracker mode has reviewed the assignments and has found some residual undulations in the mass calibration which it thinks could be corrected within the spectrum. And as with the polynomial correction, we can apply this recalibration by clicking the Apply Recal Data button. While that recalibration is being applied, it's worth remembering that these types of localized mass recalibration issues can be caused by the ion density in the instrument or the mode of use of certain designs of mass spectrometer. Because in this case we're applying Tracker mode after the gross polynomial correction, we don't see a huge difference in the data, but it has had an effect. The final mode we'll look at just now is Walker mode. Walker mode is a walking style recalibration method that looks for much shorter scale mass recalibration issues in the data. You would know if you had the sorts of issues that this walking calibration can correct for, if when you zoom into your data you can see that there are short range mass error trends across multiple 1 or 2 Dalton ranges in your results, so that the mass error plot looks like a saw blade when you look at the detail. Commonly these might be resulting from some issue with the way the instrument has been set up, but this walking recalibration will allow those issues to be partially corrected for. However, on normal data such as we have here, this Walker mode would be overfitting the data and so would not normally be used. However, as we have this file open, we'll use it for demonstrating how to set Walker mode up. So to select Walker mode, again you go back to the recalibration dropdown and choose the Walker option there. And then re-import all the current assignments. And then you can apply this recalibration the same as we have for the other modes. Because of the potential for Walker mode to overfit your data, it's not a recalibration mode that I would use commonly, unless I was specifically working with data which really required it. So in summary, my recommended recalibration workflow for data in AutoLogis is to apply a 5th order polynomial recalibration to all assignments as my first and main stage of recalibration, and then if I need a more advanced, higher accuracy recalibration again after that, I would apply Tracker mode again to all assignments, but only after I'd already applied the polynomial recalibration. As with all of these AutoLogis help videos, I hope this has been useful, and if you need more information or help, you can contact us directly at kilgourlab.com or speak to one of the team at SpectraSwiss.